today. We've got kind of a list of things, hopefully, to get covered. If we're really lucky, but I'm not sure if we will. And we'll get 5.3 finished today. So let's start off with kind of repeated yesterday. Finding amplitude, period, and horizontal shift of a trig function. So you got that guy. Okay, now, oops, I should put a number here. There we go. That number there tells you the amplitude. And so that's 3. That number there doesn't tell you the period, but you can find it by using the formula that the period is 2 pi divided by that number. So in this case, that's a half pi. And that guy there also needs that guy. So it's a combination of these two. And that gets you what is called the horizontal shift. And the horizontal shift is basically this guy. I'll try to be consistent. Did I call them BX and C yesterday? I mean, it doesn't really matter, right? So if I call this guy B and I call this guy C, then you get it by taking C and you divide it by B. In this case, you take pi upon 3 and you divide it by 4. And with a little bit of work, and you can use your calculator, that the horizontal shift is pi upon 12. And we talked yesterday about if that's negative, won't the horizontal shift be positive? And if that is positive, won't the horizontal shift be negative? Unless they're really sneaking, stick a negative here, in which case all bets are off, right? So far, so good. Right. Now, as long as you know where to get the numbers, you are good. But sometimes they make your life, awkward, I guess. There's -2. No, the cosine has no great significance. There's at least one person who contacted me about a question that looks something similar to that. And let's do it then. The amplitude is clearly just negative. Oops, I almost made a mistake. Isn't the amplitude always positive? So it's 2. The period is not going to be an issue. Well, maybe it is, I guess. If you look at this question, you need to take 2 pi, right? And you need to divide it by somebody, right? In this case, isn't it the 4 because it's 4x? What number will I use in this case? Will it be 1 or will it be, I guess, 3? That's the choices. What makes more sense? Kate's doing her fingers. I agree with her. 3. Now, this is the one that really stuck the person, and I can understand why, because it's not really the usual way. Do you know how normally you do C over B to get the answer? And you can certainly do that. But when it's written in this very special format, you actually get the answer for free. It's that number. Now, if you want to see where that pi upon 3 comes from, if I multiply this out, right, I'll do it down here. If I take just this piece of the puzzle, right, that bit there, if you multiply it out, you get 3 times x is 3x. 3 times that guy gets you pi. There's your B, there's your C. Can you see that it's C divided by B, it's pi divided by 3. Do you see you get the answer, right? I just think it's easier if you recognize that when they've already taken the factor out and left an x plus something or an x minus something, you can actually get the horizontal shift directly. So you don't even need to do a calculation. But if that's something that kind of is hard for you to see, why don't you just multiply it out, right? And then you can use the formula. It's going to get you the right answer, correct? So I don't think there's a biggie there. Do we feel comfortable now about if you get a sine or a cosine in this format, right, with all these bits and pieces going on, that you're comfortable about finding an amplitude, finding the period, and finally getting the horizontal shift? You feel good about that? Right. Now, someone else today came up with, I think it's a good point. Do you know how very often at the end of these, they give you 4 pictures and you're meant to pick the right one? And it's not always that obvious which one the picture is, because you tend to get, their pictures tend to look like this. They start at negative pi, right, and they finish at pi, and you know, you just get like a piece of the puzzle, right? When you put it into Desmos, don't you get one of the guys that always looks like that? And therefore, it's a little bit hard for you to see how that might be this guy, right? Because they all kind of blend in each other. So I'm going to show you a little bit of a trick here on how you can do it. And so imagine that you were given 4 pictures. And one of them was going to be this guy. And this picture here went from negative pi to pi. And this picture here went from negative pi to pi. And this one here went, so negative pi upon 2 to 3/2 pi. And finally, negative pi upon 2 to 3/2 pi. And do you notice that the range of x's is kind of different in the top 2 compared to the bottom 2? And wouldn't it be nice if you could just get Desmos to draw this guy in this range or this range? And that way it's a much easier comparison, right? So that's what I'm going to show you right now. So if I click on my window, I better have Desmos floating around. And we have, okay. And I have, actually, I think that was the question that one of the persons did. So let me show you. Well, let's just kill it. So I'm doing it from start, right? I want to do just a window from negative pi to plus pi, right? That's all I want to see. I don't want to see the rest because it's a distraction. So you do a little curly bracket and you type in negative, remember where it is now, negative pi less than or equal to x less than or equal to pi. Then you do a colon. And you don't write down y equals 3 sine x, etc. You just write down the 3 sine x part. And make sure you finish with the curly brackets. Right, you see that guy? Now, if I click off this window, can you see? That's the picture that you're going to see as one of the 4 guys at the bottom. It might not look it, but that guy there is negative pi, and this guy over here is pi. Now, maybe they give you the window from negative pi upon 2 to 3/2. Right? Well, if you want to change the window, well, actually, let me copy this one, show you. Then you can change that to pi upon 2, and you can change that one there to, there we go, 3/2 pi upon 2. Now, I'll make the green one disappear for a minute. Can you see the guy is now kind of more to the right? And that would be one of your 4 pictures. Now, who knows what they do? I'm just saying it's 3 upon 2 pi. Couldn't it be, I don't know, anything at all? Couldn't it be from a quarter, from a third, maybe to 2/3? Now, if they did that, do you see how the picture changes? Because they've narrowed what you want to see. If you want to see it a bit bigger, you can do that. And I think that might help you when you come to the last part of the question. Which one of these 4 graphs is my guy? Hopefully that is helpful. Some of you didn't really need to do that because you could kind of figure it out just by looking. You know, you could just focus on the bit and see it. But I think that might be helpful for some of you at least. So let's return to our notes and see where we are right now. So essentially, we have done amplitude, periods, and horizontal shift of guys that look like that. Okay. But let's move on to amplitude and period and horizontal shift of guys that look like that. Good news is I do not need to do really that much extra. Okay. You want to find the amplitude. You get it from there. So it's still 3. In fact, for all intents and purposes, don't you just cover that 4 up? Right, because it doesn't actually change the amplitude, the period, or the phase shift, right? That 4 does something else, and we'll talk about that once we've got that covered. So that's the amplitude. I want to do the period. So it's 2 pi divided by that number. So it's pi. And I want to do the horizontal shift. So that's B and that's C. So it's C over B, and it's pi over 2. Positive because of that. Does anybody know what that 4 does?
It shifts the entire wave up.
Yeah, it does. So I'm not making any attempt to do this accurately, but can you imagine that this might be what 3 cosine x looks like? Right? You know, it goes up to 3 and it goes down to -3. Right, can we pretend that's it? When you stick a 4 on, all you basically do is move everybody up. I think I need a little bit more room. You move everybody up 4. Right, and that guy there moves it up 4, you get to it there. And that moves up 4, you put in a little invisible line and just help me draw it. And you would get a curve that looks like that. Don't know how well I've done that, but can you get the impression that I've moved everyone up 4? And that's what it does. So if someone asks you for amplitude, period, or horizontal shift, and there's an extra number there, will you just basically ignore it? Because it doesn't change any of the 3 answers you're trying to find. And when it comes to the sketch, of course, you have to put it in then, don't you? So you can actually pick the right picture. But that's what Desmos does, right? It'll figure it out for you. Are we good with that? Do you want to see another one that's got a 4 or a 2 or something on it? Or are you good? You're good. What happens then? I'm trying to keep everything else as much as I can the same. What happens if you sketch that guy, or you're trying to find its amplitude or so on? Well, let me go by the quick one. The amplitude, period, and horizontal shift does not change, isn't it? Amplitude is 2 and the other 2 are what they are, right? All I'm interested in, what would that do to a normal sine function? So if you do a normal sine function that looks like this, what does a negative? The 2 is not important, but what does a negative do?
Means it begins by going down.
Right, so you reflect it in the x-axis, so it would look like this. Right. Isn't that exactly the same thing as x squared looks like that and minus x squared looks like that? You remember 141? If you put a negative in front of a thing, isn't its visual effect is to reflect it in the x-axis, right? Whatever the first shape is gets reflected. So again, that has no effect on amplitude, period, or phase shift. You agree it's the same phase shift whether that was 2 or -2. If you put both together, doesn't it turn me upside down and then moves everybody up 3? But isn't the amplitude, the period, and the horizontal shift still the same guys as they always were? So these various transformations are not going to directly affect any of the 3 major pieces to the puzzle, right? The only major effect they're going to have, and it is a major effect, isn't the shape going to be either reflected in x-axis, right, upside down, or it's going to be moved up or down, or both things, reflected and then moved up, right? It's going to be changed in some visual way, but the main structure is impervious to those things. Any questions? Now, are we good? Okay. Lots of nods. One of the reasons I like to see pictures, as I can see all of you, I can tell from nods. Looking for the next feature, which is how do you create an equation? So I'm trying to pick a couple of questions here that have that going on. You never find things when you want them, but they're around, so I know if I keep looking, I'll get one. And here we go. There's an example of this. My numbering is wrong, that's why I couldn't find it. You'll find a question 13 that looks like this. And you find another one, question 14, that look like this. And that's it. Okay. So here is my first question. You're going to get a graph of a trig function, a sine or a cosine. In this case, it's a cosine. And they're going to give you just enough information for you to come up with its equation. Right? And the things that you should be able to get from a graph, if you look carefully enough, is you should be able to find the amplitude, the period, right, and the phase shift. Right? That should be possible if the diagram is drawn accurately enough. So my thing disappeared on me. So where the heck are you? I've lost the question. Can you remember what number I said it was? Oh, 13 is in front of me. I changed one of the screens, and the minute it changes the screen, this kind of resets, and it's a pain in the butt. Okay, finally got you, guy. This guy here is 7, and it curves down here, and it curves up here, and it looks on like that. Okay, and there's a guy here who's at pi upon 4. There's a guy here, but they didn't tell me who it was. There's a guy here at 3 pi upon 4, and there's a guy at the end, but they never told me who it was. And that's pretty much all I've got to work with, right? A very primitive piece of a trig function. So this is the process I'm going to use. First thing is step 1. Find the amplitude, find the period, and find the horizontal shift, if it's got one. First things first, we're told that this is a cosine function, right? Because see, if you take a sine function and you shift it, doesn't a sine function look like a cosine function? Right. So this is a cosine function. Now, amplitude, I think it's staring me in the face, but I'm going to ask the question anyway. On this picture, what is the amplitude?
7.
Are you all comfortable about why it's 7? You see it in front of you, right? Now, the period is a little bit trickier. They did give me numbers. They gave me 1/4 and 3/4 pi. But the period is the distance from there to there. Right? The period is how long does it take to repeat itself? Would you agree that from there to there is one cycle? Can anyone make an intelligent prediction on what the period is, even although they haven't told me that number?
Pi.
I hear you. Is there a logic to that or a guess? If you've got a logic to it, I'd like to hear it, anybody. Why you pick, it's correct, by the way.
The first point it's given is 0 pi over 4, and the third point is 3 pi over 4.
Mm-hmm.
So the center point would have to be pi over 2, and the next point after that would be pi.
So you basically figured out what each little jump was and figured out it was pi. Does that sound roughly what you're saying? Yeah.
Yeah.
Yeah. In fact, it isn't that halfway. So if you double that, you get that. That's another way of looking at it. Isn't there lots of ways of looking at it, right? But as long as you came up with pi, there's a good chance that the way you were looking at it made sense. Now, this particular question doesn't have any horizontal shift. Now, you might say, well, how do I know it doesn't have a horizontal shift? If you draw the normal cosine function, doesn't it start there? If this had a horizontal shift, wouldn't it look a little bit more like this? do you see that the hill would have moved, in this case, to the right? Maybe I'll make up that's pi upon 6, right? Can you imagine it would have, physically, you would have seen the difference. So if you see a shape like this and it's a cosine, you will assume that the horizontal shift is 0. In other words, it doesn't have one. That makes sense? If you see a cosine function that doesn't start here, right, but kind of starts like here, right? You see a little movement. Can you see that the phase shift is going to be pi upon 6? I'm not sure I'm seeing happy faces here. Does that make sense? I'm calling it, the horizontal shift here is 0, and the horizontal shift here is pi upon 6. Okay, I'm getting nods, right? That's fine. Well, that's phase step 1 done. Find these 3 guys. Step 2. We know that this guy, and I'm picking up my
Just
own
to
letters.
clarify,
Yes.
so the horizontal shift is the closest point to 0 that you hit the peak of the wave.
So you're saying, if I'm hearing you right, that distance there is a horizontal shift?
Yeah.
Yes, I agree with you.
Okay.
Now, I'm going to write down a general version of all cosines that haven't been moved up or down. A cosine bx, and I have to put something, so I'm going to put plus c. Remember my b and my c from earlier, I'm using the same letters. Now, these guys will help me get A, B, and C, okay? But only one of them you get for free. The amplitude is 7. So I'm doing this really slowly. Since the amplitude is 7, can't I now write 7 cosine of bx add c? Are you comfortable about that? That's pretty straightforward. Agreed? The amplitude 7, the formula is 7. Now, I know the period is pi, but I need to know what b is, right? So that's going to be a little bit trickier. The period is pi, and I know that b, or I'm trying to find b, right? Can you remember the formula that we used to calculate the period? Wasn't it 2 pi over b? Agreed? Now, if I know the period is pi, haven't I now got that? So far, so good? Right, so essentially, don't I just need to find out what number b has to be to get pi? You could do that one in your head. Would you agree it's 2? But let's suppose it's a really ugly number, like 7/9, right? Something you couldn't do in your head. Do a little cross multiply. B times pi is 2 pi. Divide both sides by pi. And you now get b. Do you see where that came from? There's another way to do it. B is equal to 2 pi divided by the period. Right, so the coefficient of x, the guy I'm calling b, can be found by taking 2 pi and dividing it by the period. So let's see if that works. 2 pi divided by pi is equal to 2. Now, do you like to do it this way, or do you like just a formula that you plug in? That's your brain, that's what suits you, right? Some people don't like formula because there's just so many of them. Some people do because it's easy, you know, you just find the right formula and you plug them in, right? Now, that means that we now have y equals 7, the cosine of 2x plus c. Would you agree we're much closer to being finished? We only need to find c now. Right. Now, before we even talk about c, let me do some more examples of finding b, right? Totally different questions. Suppose I had the period and it was pi upon 3, right? Because I could right? And I want to know what b is. I'm going to use the formula. It's going to be 2 pi divided by pi upon 3, right? So it's going to be, I should write this in first. It's going to be 2 pi right, divided by the period. And then I go to my calculator, and basically the pi's cancel out, so you don't worry about them. I just go to my calculator and I say, okay, then what is 2 divided by essentially 1/3? Put a little bracket around it for safety. And there we get the answer. The answer ends up being 6. Let's suppose the period was 10. Then B is 2 pi divided by the period. B is going to be 2 pi divided by 10. In this case, do you see how B ends up being a rather strange 1/5 pi value? Are we comfortable now that you can find the value of B if you know the period? Right. 2 pi divided by the period is the value of B. Okay. Let's move on to the final piece of the puzzle. I need to know who C is. C is connected to the horizontal shift. Now, if the horizontal shift, so there's 2 cases here, although they're connected. First case is when the horizontal shift is equal to 0, C is 0. So our answer to this question ends up being 7 times the cosine of 2x. Technically plus or minus 0, but you know that doesn't matter, right? Now, what's more likely to happen, isn't it that you're going to actually have a horizontal shift, right? There's going to be some horizontal shift. Let's do that one. Remember that horizontal shift was pi upon 6? Imagine we had a question where the horizontal shift was pi upon 6, right? We already, I'm just going to keep the question exactly the same. So the period was still pi, right? And the amplitude was 7, right? So the only thing that's now changed is the horizontal shift. That is going to make a difference. That C is now going to be a number. And it's not, I wish it was, it's not that guy. Right? It's not that guy. But we can find it. To get the value of C, any suggestions about how we use the value of the horizontal shift to find the missing C? In other words, that guy there.
I mean, the horizontal shift is B over C. So wouldn't we have to find the period first and then
Okay,
plug that
so
in?
let's see. The formula for C, right? Right. Let's call it the formula for the horizontal shift, which is C, right? What was the formula for the horizontal shift? Can anybody remember how you got it?
It's a C over B.
It was C over B, agreed? Now, in this question here, the horizontal shift is known, isn't it? It's pi upon 3. And B we just found. So, can you see? We've got a little guy. Horizontal shift, we already know it. C, we don't know because we want to find it. And isn't B 2 because we found B a minute ago, right? It's that guy. So, a little cross multiply. And then you get C. And so, if that was the question, right, we would have y equals 7 cosine 2x minus 2 pi over 3 because the shape was shifted to the right. That means if you rearrange this formula, that C is going to be B times the horizontal shift. So if you like formula, isn't it easier just to get C by multiplying the value of B with the horizontal shift? And so just to show you the value, let's tell you what these guys are. A was the amplitude was 7, B was 2, right? We already got those. So it would be 2 times the horizontal shift. There. Can you see where the 2/3 pi came from? So you can either do it as solving an equation, or you can do it by using an equation, or a formula, I should say. Okay, there's a lot in that, isn't there? There's a lot of information that you've to get from the graph. Then you have to convert that information into the missing A, B, and C. I want to do at least one more of these, maybe 2, depends on you lot. So. This one's going to be a sine function. So this is like the ultimate version of everything that can go wrong is going to go wrong in this question. Just curious. Yep. So this is much more difficult than most questions. From what I can see, most of the questions, the horizontal shift is 0, right? That makes them a lot easier. But I want to do a really hard one to show you what's going on. Right, let's make that guy pi upon 6, okay? And I'm going to tell you that this guy is pi upon 2. I'm just doing this in my head, so it's... And this guy here is that guy. And I'm telling you that this function is a distorted version of the sine function. So first things first, let's find amplitude, period, and horizontal shift. What's the amplitude of this diagram, this sine function?
It's 4, but in the equation it'll be -4.
Oh, because of the little turn down? I want you to imagine that we started there. Do you see it's still positive? So I'm going to keep it as 4.
Yeah, the amplitude is still going to be 4, but when putting it into the equation, it's going to be -4.
Well, that's what I heard, and I understand why you're saying that. I'm going to say I'm going to keep the amplitude as 4. And the horizontal shift is what's making you think that it's turned upside down. Because if you start at that point, is that a normal sign or an upside down sign?
It's a normal sign.
So that means it's positive 4. Now, what did the phase shift do? Didn't the phase shift make you think it turned upside down because of this bit?
Yeah.
So start at the beginning. And if it looks that way, it's positive. Now, if this guy, God, I would never do this to you, but if this guy was upside down, wouldn't that mean -4? Right? If it was that way, right? That is so messy, I would never do that to you. Now, here's a puzzle for you. What is the period? Now, the period is from here to here.
Is it 2 pi over 3?
You're right. Do you want to tell everyone else where you got that from?
I did 5 pi over 6 minus pi over 6, which is 4 pi over 6. And that's simplified to 2 pi over 3.
Couldn't have said it better. Yeah, that's exactly what you did. Now, can you see sometimes they don't tell you that number, right? Couldn't you find that distance and then double it? Wouldn't that get you the same effect? So you got to work with what they give you. So would you agree from there to there is half the distance? So from there to there is 1/6, take away 3/6 is 2/6, so double it is 4/6, and that gets you 2/3. Now, the horizontal shift is not a biggie here. Right? It's in the diagram. You don't need to do any calculations. What is the horizontal shift here?
Pi over 6.
Pi over 6. Are we comfortable with that? Right. Now, we got these guys. We want to create y equals a sine bx take away c. Oh, by the way, I'm putting take away c because don't I kind of know it's going to be a negative number because of the shift to the right. Okay. Now, first one is the freebie. You agree? Amplitude's 4, that's 4. And I've kind of tried to argue with it that it is a positive 4, right? Now, the only other two guys we need to do is we need to find B, and then we need to find C. Do you want me to do it with the formula? Should we use that method to find B and C? Do you mind? Okay. B then is 2 pi divided by the period, and C is, try to find where I put my formula for C. I want to be consistent. I used C, didn't I? Yes, I did. Okay, so isn't that the formula for C, right? It's B times the horizontal shift, right? So in this question, B is 2 pi divided by the period, which is 2/3 pi. And that's kind of what calculators are for. So forget about the pi's, they cancel out. So it's going to be 2 divided by 2/3. 3. And what's C? Well, C is going to be B times the horizontal shift, which is what, pi upon 6. So C is going to be pi upon 2. And if you put the whole package together, then you get 4 the sine of bx take away C. Do you want to see another one of these, or do you think you got the gist of it? As much as I think I'm good at this job, I still haven't perfected mind reading. So if you don't tell me things, I'm looking at your faces, but actually I'm getting a mixed picture. I'm getting, really feel comfortable about this, to, I've seen enough of these, can we not do something else, please? So where are we in that spectrum? What do you want me to do?
I understand it well enough. I think we're good.
Okay. I guess you'll find out and you can see me in the office then, right? You know, if it doesn't work out, that'll work too. So finding the solutions to trig equations, or I should say that one, right? Creating it. So we've done that guy, and that guy. Right. Finding the solutions to trig equations using a calculator. Now there are going to, but what does a trig equation look like? It's basically you're trying to, you know, solve an equation and find the missing x. So here's an example of it. Question 21. Cosine x equals x. And we're only going to use it in the interval 0 to pi. Right? And so it says, find all the solutions to this equation that lie in this interval. Round off your answers to 2 decimal places. Okay, gotcha. And enter your answer as what they call a comma separated list. I know this is not the answer, but let's just pretend that there was two answers, right? There were two places where that was true. And the first one was nothing 0.12, right? And the second one was, say, 0.71, right? Just for argument's sake. A comma separated list looks like this. 0.12, comma, 0.71. That's all they want you to do. What can go wrong? People will write x equals 0.12 and x equals 0.71. And if I was in charge of WebAssign, that's actually how I would prefer you to write it. Doesn't that make a little bit more sense? But if you write that, WebAssign will say wrong. Right? It's pernickety. That's what it wants it to be. Now, if there's three answers, don't you just do a comma in the third answer, right? If there's only one answer, it's a little bit easier, don't you just write one of them down? So be comfortable about this comma separated list is. So you can't do that algebraically, right? You can't, double both sides, take the square root of both sides, the usual solving algebra equations doesn't work. That's why you're going to use the calculator and or Desmos. I'm going to show you both the calculator and I'm going to show you with Desmos, because some people are just comfortable with the calculator and that's the way they want to do it. Plus they can, they don't need to have, all these windows on. So this is the calculator way first. What mode should my calculator be in if I'm going to do this?
Radians?
Radians. It better be, but you never know. Because the first time I don't check that is the first time I should have checked it, right? Because, you do it all right and you got it in degrees and horrible things happen. Okay. So you go into y equals and you put in cosine x. And you press enter. And you put in the other side, in this case, x. That's not too difficult. You then go to window and you pick a window x min starting at 0 and finishing at pi. Okay. 0 to pi. And I then hit zoom button and I do zoom 0 because that way I let the calculator do all the clever stuff. Right. Can you see the cosine function doing its thing? Can you see the straight line, the x thing? We are interested in when those two things are equal. So essentially, aren't I looking for the x coordinate of that point there? Now you can do that on the calculator. You just hit blue button where it says trace calc. So blue button, calc. And the one I want to choose is option number 5, intercept. And let me get one of my little mumps over with. The TI-84 is a really nice calculator. It does a lot of things. If you've got a modern one, it's color, which is even better. But it has some idiosyncrasies, which really drive me crazy, and this is one of them. I'm about to hit enter. And you will see it will ask you first curve. Don't worry about the numbers, that's not important. If I move my little cursor, do you see I am on first curve? You see as I drive along my little car, you can see I'm on the cosine. All it wants me to do is say who's the first curve. So I hit enter. And then it gets annoying because it says who's the second curve. Would you agree there are only 2 blinking curves there? Why do you need to ask me who's the second one? It just seems stupid, but it does. So I'll humor it. That is my second curve. I'll drive along it. Can you agree? That's my second curve, my straight line. And then I hit enter. And then it annoys me even more by saying, could you guess? If I wanted to blink and guess, why would I use your calculator, right? I don't want to guess. I want to answer. What it really wants you to do is just to make sure that, see that little car, I call it my little car, see me driving it? Just make sure it's near the thing. I think that just makes its life easier, but I don't think it makes a big difference if you just hit enter. Because do you know, normally when I do these, do you know what I do? I just go enter, 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 and stop looking at the question. Because the first enter is the first curve, the second enter is the second curve, and the first enter is my guess. And I'm not going to change anything, so why bother, doing it? There, I got my mump over with. I feel so much better. So, yes. And the answer, the bit that we're interested in, is this number here. So 0.7390. So that's x equals 0.7390 and a whole load of stuff. Oh, I want 2 decimal places. So will you remember to do what it says? I believe WebAssign will do this to you. Can you imagine that? Actually, I've just made a mistake. Isn't that what you need to write inside the box? If you, however, give it more than it wants, I think WebAssign at least sometimes will say you're wrong. Not because that's wrong, but because it's not rounded to 2 decimal places. So it's just one of those, because sometimes they ask for 6 and sometimes they ask for 2 and they do all sorts of other things in between. But that's how you would do it on the calculator, right? And now I'm going to do it using Desmos. And I'll have to be really quick because I just realized while I'm doing this, why don't you put your last name down for attendance? Because time has beaten us. Right. So I'm going to type in y equals cosine x. There we go. I'm going to type in y equals x. Right, let's click off that somewhere. Right, you see it's pretty much the same thing, but a lot quicker. I like Desmos myself. It's got color and you can zoom in, right? And I don't need to do first curve, second curve, or any curve. Do you know, I just go to that guy and I click on it. And if I hold my mouse point on it, can you see 0.739? And to 2 decimal places, isn't that 0.74? Now, as long as they only want the answer to 2 or 3 decimal places, you're fine, right? 1, 2, 3. If it says to 4 or 5 or 6 decimal places, you have a bit of a problem there because it doesn't tell you. So you would probably want the calculator for really accurate answers. But I think Desmos is such a cool piece of software, isn't it? Just,
Yeah, definitely.
it's more intuitive. It's kind of, you know, what you see is what you're going to do. Anyway, bye-bye for now, guys. See you tomorrow. I'll hang about for a question. That's us.
Professor, do you mind if I ask a question?
Sure, go for it.
This is based off of earlier
Uh-huh.
with that sine function. So when we're doing a sine function, is there a point in which the horizontal shift can change the amplitude of the equation? Because from what my understanding is a sine function would always be positive.
If you do a horizontal shift so much that the thing looks upside down, you could have 2 correct answers. One of them will always be a positive one, Matthew. Right? But
Okay.
you know, if you take a sine function and you give it a horizontal shift of pi, do you know it ends up looking like an upside down sine function?
Mhm.
So the 2 interact. So why don't we work on the assumption that it's always positive, in which case the horizontal shift is, you know, how much to the right you move it.
Okay.
And that will be a correct answer. Now, that doesn't mean there might be a second different looking
Mhm.
correct answer, because there will be, but we're not going to go looking for that one.